factor to x plus 5 and x minus 2. Both fractions have the factor of x plus 5. The extra factor of x minus 2 we'll need to put on the first fraction for the numerator and denominator. That way both fractions have common denominators. Multiplying the first fraction using FOIL, x minus 2 times x plus 3 would be x squared. X times 3 would be positive 3x. Negative 2 times x would be negative 2x. And negative 2 plus 3 would be negative 6. The plus 6 we can bring down from the numerator. And the denominators again are both the same, x minus 2 and x plus 5. Simplifying, the negative 6 and positive 6 would cancel. 3x minus 2x would be a single x, so the numerator would be x squared plus x. And the denominator, if we FOIL that back out, would be x squared plus 3x minus 10. So the correct answer, letter A, x squared plus x over x squared plus 3x minus 10. Looking at the unit circle is on the xy axis. The unit circle is centered at the origin, 0, 0, and also has a radius of 1 for the circle. So the 4 endpoints are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. If you look at the first quadrant, which is in the top right-hand corner, starting on the inside of the unit circle, 0 degrees starts on the x-axis, and as you go around counterclockwise, the degrees increase. The first 3 degrees will be 30 degrees, 45 degrees, 60 degrees, and 90 degrees. It'll continue around the circle until you make one full revolution, which will be 360 degrees. Instead of degrees, you can also use what's called radians. Radians again start at 0 on the x-axis and increase as you go counterclockwise. The first radian is pi over 6, then pi over 4, pi over 3, and pi over 2, and it continues all the way around until you have 2 pi, which is the distance around the circle in terms of radians. The endpoint again, the first point is 1, 0, and then you have 3 fractions that represent the points for the degrees and radians, and then the top point is 0, 1. Looking at the 3 fractions or 3 sets of points, every number x and y is a fraction over 2. The numerators also have a pattern, which is a U shape going from top to bottom and back up to top. It goes in order of 1, 2, 3, and counts back up for the y values of 1, 2, and 3. The numerators all have a square root on top, except for the 1s, which if you take a square root of 1 would simplify to just 1s. The other points directly across and directly below are the exact same points, with positives and negatives represented for the x's and y's. Title of the first section today is Changing, Degrees, and Radians. In this section, we'll look at how to change degrees to radians and also radians to degrees. The one definition or step that we'll use for this section is multiply by pi over 180 degrees, or the reciprocal of that, 180 degrees over pi. If you look at the unit circle, halfway across the unit circle, the pi matches up with 180 degrees, so these two units are equal, and also 180 degrees over pi both units are equal. So by multiplying by pi over 180 or 180 over pi, we're basically multiplying by 1. First question we'll look at is 130 degrees. We'll take the degree measurement and we'll change that into radians. Instead of a degree symbol, radians will be left with a pi symbol. To change degrees into radians, we'll multiply by either fraction. The fraction that we want to use, if we start with degrees, we want to use the fraction with the degrees in the denominator. So we'll multiply by pi over 180 degrees. Multiplying, the degrees would cross cancel. You could also divide by 10 or cross out the zeros. And we'll be left with 13 times pi divided by 18. And what this means is 130 degrees is the same as 13 pi over 18. Second question, and last question for the section, 3 pi over 4. In this case, we'll start with radians. Radians, again, always have a pi measurement, and we'll change radians into degrees. To change the units again, we can multiply by a fraction. Whichever units we start with, in this case we start with pi, we want to have pi in the denominator, so we can cancel out the pi's and we'll be left with degrees. So the other fraction that we can use is 180 degrees over pi. Multiplying or reducing, the pi's again will cross cancel, so our final units will be left with degrees. You could multiply 3 times 180 divided by 4, or if you want to cross cancel the 180 and 4, taking 180 dividing by 4 would be 45, and we'll be left with 3 times 45, which will be 135 degrees. So again, what this means, the radians 3 pi over 4 is the same as 135 degrees. And looking at the unit circle in quadrant 2 in the left-hand corner, if you find 135 degrees, it is equivalent to 3 pi over 4. Title of the last section today is Finding Positive and Negative Coterminal Angles. In this section, we'll find a positive coterminal angle and a negative coterminal angle. A coterminal angle means the same angle, but written as a different fraction or different number. The definition or way to find coterminal angles is add / subtract 360 degrees or 2 pi. Looking back at the unit circle, 360 degrees is one entire revolution, and 2 pi is also one revolution around the circle. So if you add 360 degrees, you'll end up at the same spot, or if you add 2 pi, you'll end up at the same spot on the unit circle. With subtracting, you'll go clockwise around, but again, you'll end up at the same exact spot on the unit circle, which will give us a coterminal or equal angle. First question is 225 degrees. For 225 degrees, we want to find one positive coterminal angle, which will be a positive number, and a negative coterminal angle, which will be a negative number. We can first add 360 degrees to get a positive coterminal angle. 225 plus 360 would give us our first answer of 585 degrees. What that means is 225 degrees is the same as 585 degrees, except 585 degrees has one extra revolution around the circle. To find a negative coterminal angle, we can take the original angle of 225 degrees, and instead of adding 360, we can subtract 360. 225 minus 360 would be negative 135 degrees. So for the angle 225, a positive coterminal angle is 585, and a negative coterminal angle is negative 135. Second question, is the radian measure 3 pi over 4? Taking the radian measure of 3 pi over 4, we can find a positive and negative coterminal angle that is still in terms of pi or in terms of radians. Instead of adding 360, when we have the units of pi, we can add 2 pi. And again, 2 pi is the same as 360. It's one revolution around the unit circle. 3 pi over 4 plus 2 pi. If we make them fractions over 1, we can get common denominators and add from here. 3 pi over 4 would stay the same. Plus, changing to a common denominator, we can multiply by 4. So 2 pi over 1 is the same as 8 pi over 4. Adding straight across, we'll have 11 pi over 4. And that'll be our positive coterminal angle. 11 pi over 4 is the same as 3 pi over 4, except 11 pi over 4 has one extra revolution around the circle. To find a negative angle, we can take the original angle again in radians, 3 pi over 4, but instead of adding 2 pi or adding 8 pi over 4, we can subtract 8 pi over 4. 3 pi minus 8 pi would be negative 5 pi over 4. So we have one positive and one negative coterminal angle for the radian measurement 3 pi over 4. And last angle we'll look at is 400 degrees. Again, to find a positive coterminal angle, we can first add 360 degrees. 400 plus 360 would be 760 degrees. So a positive coterminal angle of 400 degrees is 760 degrees. To find the negative, again, we can take the original angle. Instead of adding, we can subtract 360 degrees. 400 minus 360 would be 40 degrees. Again, we want a negative coterminal angle, which means the answer should be negative. Anytime you subtract 360 and you have a positive number, if we want to get a negative number, what we can do is take our answer 40 and subtract 360 again. Each time we subtract 360, we're taking away one revolution from the circle. So if we subtract once, it's still positive. We can subtract a second time, and we'll still be at the same spot on the unit circle, but will be one less revolution. So 40 minus 360 would be negative 320. So a positive coterminal angle will be 760 degrees. We could also use 40 degrees as a positive coterminal angle, and the negative coterminal angle would be negative 320. review trigonomic functions. The two basic trigonomic functions are cosine and sine. When using a unit circle, cosine will be represented by the x value and sine will be represented by the y value. The other trigonomic functions, tangent. Tangent is sine over cosine, or in terms of x and y, tangent is y over x. Cotangent, cosine over sine, can be changed to x over y. And secant, which is 1 over cosine, can be changed to 1 over x. And cosecant, 1 over sine, is the same as 1 over y. Title of the next section is Find the exact value of each trigonomic function. Given the basic trigonomic functions and the unit circle, we can find the exact value for any point on the unit circle. First question we'll look at is the sine of 300 degrees. To find the sine of 300 degrees on the unit circle, you can first locate 300 degrees, which is in the fourth quadrant in the bottom right hand of the unit circle. The sine value again is the y value. So the sine of 300 means the same as the y value of 300 degrees, which would be negative radical 3 over 2. So using the unit circle, finding the exact value of sine of 300 degrees, the sine value would be negative radical 3 over 2. Second question is tangent of 5 pi over 3. Again, you want to first locate 5 pi over 3 on the unit circle. 5 pi over 3 is also in the bottom right quadrant, the fourth quadrant. The tangent, looking back at the definitions, is y over x. So using 5 pi over 3, we can take the two values, y divided by x. The y value of 5 pi over 3 is negative radical 3 over 2. And divided by the x value of 5 pi over 3 would be 1/2. So again, the tangent is the y divided by x. Simplifying, if we're dividing by a fraction, dividing by 1/2. Instead of dividing by 1/2, we can multiply by the reciprocal, which would be 2 over 1. Multiplying straight across, or we can also cross cancel the 2's. We'll be left with negative radical 3 over 1, which is the same as negative radical 3. So the tangent of 5 pi over 3 is the same as negative radical 3. And last question for the section. Secant of 19 pi over 6. First again, you want to locate, if possible, 19 pi over 6 on the unit circle. 19 pi over 6 is not on the unit circle. The reason for that, if you do 19 divided by 6, 6 goes into 19 actually 3 times with 1 left over. The unit circle again only goes up to 2 pi. So if 19 divided by 6 is bigger than 2, 19 pi over 6 will not be on the unit circle. To look this value up though, what we can do is find a coterminal angle. If the angle is too big for the unit circle, we can subtract off a coterminal angle to find a smaller angle to look up. In terms of pi, if you remember, you can subtract 2 pi, since 2 pi is 1 revolution in radians around the circle. Taking 19 pi over 6 and subtracting 2 pi, getting common denominators for 2 pi over 1, that would be the same as 12 pi over 6. 19 pi over 6 minus 12 pi over 6 would be 7 pi over 6. 7 over 6 is less than 2, So 7 pi over 6 should be on the unit circle, and it'll have the same secant value as 19 pi over 6. Locating 7 pi over 6 on the unit circle, that would be in the third quadrant in the bottom left-hand side. Looking for the secant value. Secant, again, is 1 over x. So the 1 would stay the same, and we want the x value for 7 pi over 6, which would be negative radical 3 over 2. Simplifying from here, we cannot have a fraction in the denominator, and we also cannot have a square root or radical in the denominator. Dividing by a fraction, we can first multiply by the reciprocal. Negative radical 3 over 2 would be 2 over negative radical 3. 1 times 2 over negative radical 3 would stay the same, so we'd have 2 over negative radical 3. And again, we cannot have a radical inside the denominator. To cancel out a radical, if you remember, you can multiply by that same radical, radical 3, for the numerator and denominator. Multiplying straight across, 2 times radical 3 would be 2 radical 3. The denominator, radical 3 times radical 3, would be radical 9 or square root 9, which would be 3. And bringing the negative over, we'll have the answer of negative 2 radical 3 over 3, which is secant of 7 pi over 6, which is the same as secant of 19 pi over 6. Find the values of the 6 trigonomic functions. Given a right triangle, we can use an angle such as theta to find the 6 trig functions of theta. Knowing 2 sides of a right triangle, 3 and 4, before we find the trig functions, we need to know all 3 sides or the hypotenuse of the right triangle. Using Pythagorean Theorem of a squared plus b squared equals c squared, 3 squared would be 9. Adding to that b squared is 16 would give us the value of c squared, or the hypotenuse. 9 plus 16 would be 25, and taking the square root, c would equal 5, or the hypotenuse of the right triangle would be 5. From here, we can find the 6 trig functions. The 6 trig functions again are sine, cosine, and tangent, and also cosecant, secant, and cotangent. If you remember from previous math classes, sine of theta, sine is opposite over hypotenuse. So using the angle theta, opposite would be 3, and the hypotenuse would be 5. So the sine of theta would be 3 over 5, or 3/5. Cosine of theta, cosine is adjacent over hypotenuse. Adjacent would be the sine next to theta over the hypotenuse 5, so cosine would be 4 over 5. Tangent of theta. Tangent is opposite over adjacent. Going opposite of theta would be 3, and adjacent to theta would be 4, so tangent would be 3 over 4. For the other 3 trig functions, cosecant, secant, and cotangent, we could use the same right triangle, or we can also use the answers that we found of sine, cosine, and tangent. Cosecant, if you remember from previous sections, is the reciprocal, or 1 over sine of theta. If sine is 3/5, 1 divided by 3/5, or the reciprocal of 3/5, would be 5 over 3. So cosecant would be 5/3. Secant, similar to what we did with sine, cosine would be the reciprocal, or 1 divided by that fraction. So secant would be 5/4. And last trig function, cotangent, taking the reciprocal of tangent, cotangent would be 4/3, or 4/3. And those would be the 6 trig functions given the right triangle. Find the value of x by using a trigonometric function. Given the following right triangle, one side is labeled as 10, the other side is x, and a degree is also labeled as 30 degrees. Using one of the trigonometric functions, we can find the value of x. Looking at the given information from the angle, we know the opposite side from the angle is what we're looking for, and we also know the value of the adjacent side. So using the opposite and adjacent sides for trigonometric functions, opposite and adjacent would be the tangent function. If we take tangent of 30 degrees over the adjacent, or in this case x over 10. Solving for x, we can multiply both sides by 10, and we'll have 10 times the value of tangent of 30 is equal to x. This will be one possible answer you can leave. If you wanted to further simplify, you could use a calculator for the tangent of 30, or you could also do the unit circle for tangent of 30. Using a calculator, 10 times the tangent of 30 would give you the decimal of 5.8. So looking back at the right triangle, the distance of x, or the length of x, would be 5.8. Second question, and last question for the section. Looking at this triangle, we're given one side of 32. We want to find the hypotenuse of the triangle, which is x, and the angle this time is 23 degrees. Looking at the angle given, we know the adjacent side is 32, and we want to find the hypotenuse. So having the adjacent side and the hypotenuse, the trig function for that would be cosine. Taking cosine of the angle, cosine of 23 degrees is equal to, cosine is the adjacent over hypotenuse, or in this case 32 over x. To solve for x or isolate x when it's in the denominator, one way to do so is to multiply by x to cancel out the denominator, and multiply the opposite side by x also. So rewriting the question, we have x times the cosine of 23 degrees is equal to 32. And last step, to get x by itself, we can divide by cosine of 23 degrees. And we'll have x equals the fraction 32 divided by cosine of 23 degrees. And again, if you wanted to, you could use a calculator to find the cosine of 23 degrees. 32 divided by the cosine of 23 degrees is equal to 34.8.